In the last video, we saw that some polynomial functions can be written as an easy transformation of a more basic function, and this allows us to sketch their graphs. However, in general, sketching graphs of polynomial functions is much more complicated. Let me show you a few examples that we can talk about. Here we have the graphs of 4 polynomial functions. The first two are 5th degree functions, and the last two are 4th degree functions. For the 5th degree functions, these have a couple of things in common and a couple of things that are different. What they have in common is that as we go to the right, at the end, we're increasing, and as we go to the left, we're going downward. And this is because the end behavior, which means what's happening at the end of the graphs of a polynomial, only depends on its leading term. So because these are both 5th degree polynomials, they're going to be going up to the right and then down to the left at the very end. Now what happens in between can be different depending on the other terms. But when we have a 5th degree polynomial, one thing that's true is that the most number of directions the graph can be going is 5. So here it's going up, down, and up. That's 5. But it's possible to have fewer directions. Here we're just going up from left to right. So it's possible that it'll be less than that. These graphs are both 4th degree polynomials, and their end behavior is going upward both to the left and to the right. This is going to be true whenever we have an even degree polynomial. We will see an exception where they're both going down, but we'll talk about that in just a moment. But what we have here is that in the middle, this one's just going down and up, so 2 directions, but this one's going down, and up, 4 directions. In general, the degree of the polynomial tells us how many different directions it can go in. If we had something that was a 7th degree polynomial, for example, it might go up, down, and up, or it certainly could change directions fewer times than that. The degree gives us the most number of directions that we can go as far as increasing or decreasing as we move from left to right. Now, what happens in the middle of the polynomial is quite complicated, and this is something that we're going to take several classes to look at. But what we can look at right away, because it's probably the easiest part, is the end behavior of these polynomials, which means what's happening as we go to the right and what's happening as we go to the left. And we have a nice little diagram that shows the different possibilities. The end behavior of the polynomial p of x equals a sub n x to the nth plus a sub n minus 1 x to the n minus first plus ... all the way down to a sub 1 x plus a sub 0, where all of these a's are coefficients, is determined by the degree n and the sign of the leading coefficient a sub n as indicated in the following graphs. So when the polynomial has an odd degree, it's going to be going up to the right and down to the left, like we saw up here, if we have a positive leading coefficient. If we have a negative leading coefficient, if either of these x to the fifths were negative, then it's going to be going up to the left and down to the right. If we have an even degree, it's either going to be going up in both directions or down in both directions. If the leading coefficient is positive, like these examples up here, it's going up in both directions. And if it's negative, then it's going to be going down in both directions. And we have some specific notation that we can use to talk about going up and going down, but in a much more mathematical way. So let's take a look right here. This says y is going towards infinity or approaching infinity as x goes towards infinity or approaches infinity? Well, if the x value is getting closer and closer to infinity, that basically means we're moving to the right. And if y is getting closer and closer to infinity, that means we're moving up. So this is saying basically we're moving up as we move to the right at the end of the graph. We don't know what happens in the middle, but once it stops changing directions, we're going to be moving up as we go to the right. Down here, this is saying y is approaching negative infinity as x approaches negative infinity. Because negative infinity on the x-axis is in the left direction, and on the y-axis it's down, this means that we're moving down as we move to the left. We can look at all of the same sorts of notations with all of these. Let's just take a look at this one, for example. This says y approaches infinity as x approaches negative infinity. Well, x approaching negative infinity means it's moving to the left. Y approaching positive infinity means it's going up. So this is saying that the graph goes upward as it moves to the left at the very end. Again, this is called end behavior because we don't know what's going on in the middle of the graph. This is just what's telling us what's happening at the ends. Let's look at one example together where we're looking at the end behavior, and then you can look at some more examples in the linked videos. So let's determine the end behavior of f of x equals negative 4x to the fourth plus 12x cubed minus 3x squared plus 90x minus 1.2. Now there's a lot going on here, including a coefficient of 90, which is quite large, but only one of these terms has any impact on the end behavior. Can you figure out which one it is? We know that the end behavior is determined by the degree and the sign of the leading coefficient, so the only term that matters is the leading term here, negative 4x to the fourth. Because the polynomial has an even degree, it's either going to be moving up on both sides or down. And because the leading coefficient is negative, this means it's going to be going downward in both directions. So what we can say is that y approaches negative infinity as x approaches negative infinity. This means we're going down as we move to the left. And then also, y is approaching negative infinity as x approaches positive infinity. This means that we're going down as we move to the right. So this is the end behavior of the function. In the next lesson, we're going to look a little bit more about what's happening in the middle of the function, specifically focusing on the intercepts.